Professor Marcela Bilek was born in what was then known as Czechoslovakia in 1968. It was a time of sweeping political reform and liberalization. But the so-called Prague Spring came to an abrupt end when Soviet tanks rolled in.
I was born in January, so I was a little baby at the time, and my father happened to be posted in Bangkok. When he heard what had happened, he just told my mum to grab me, leave everything behind, get on a plane. We applied for political asylum in Australia and came here.
She excelled at school, earning the right to apply for any university course she wanted.
I knew I liked science and I knew I liked learning.
She showed great promise as a software engineer, suspending her studies to take up an internship at the technology company IBM in Tokyo.
Walkman had just come out at that time. I had one of those and I did a Japanese lesson a day and then practiced on all my colleagues, and it was fantastic.
But although she loved the culture, she longed to be back in a science lab. And so, upon arriving back in Australia, Professor Bilek chose to focus on physics. She's now world-renowned for her contributions to the science and technology of plasma processes. Plasma is the so-called fourth state of matter, after solid, liquid, and gas.
An example actually of a plasma you can see on Earth is the aurora. If you go to Sweden or somewhere far north, you can see those glowing lights. That is a plasma in our atmosphere.
Her team uses these stainless steel vessels and electricity to create plasma from low-pressure gases with finely tuned chemistry.
And we can manipulate them using magnetic fields and electric fields.
Their work has many applications, including creating bio-instructive surface coatings that improve the way implants interact with the human body. For an implant to work, it must bond with the surrounding tissue and elicit optimal responses from nearby cells. And that's where hydrogel comes in. The jelly-like substance is similar to the matrix that holds cells together in tissue. But hydrogel is notoriously difficult to work with in devices that need to maintain a stable structure. So Professor Bilek's group created a plasma technology that can attach signaling biomolecules and hydrogel to polymers without using any chemical initiators. This innovative coating encourages the body to accept the implant. Professor Bilek says the endless possibilities keep her motivated.
If I get bored, I zone out. It definitely is a curiosity and a willingness to keep learning.
A curiosity she intends to share with others as a Fellow of the Australian Academy of Science.